All right, so lesson 56 has a few parts in it also, and so we're going to go through all of that. All right, so the first part is about finite and infinite sets, and so that's what I've written here. So a finite set is a set with a finite number of members. So for example, in my set, I have here 6, 7, 8, 9, and 10. I don't have decimals before, I don't have decimals after, so I'm not including any other numbers but 6 through 10. So that's a finite because I can count from 6 to 10. So that's where it ends. An infinite is a set with an infinite number of members. So here I have this set and it goes 1, 2, 3, 4, 5, ... which means I can keep counting. So that's infinite because I can continue to count because the numbers just keep on going. There's no end in that set with my dots. So that's the difference between infinite and finite. All right, and so then here are two symbols you'll need to make sure that you know what they look like or recognize them. And so this is indicating the membership in a set. So if it's asking me a question and wants to know if something is a part of a set, I will see this funky looking E here. If it wants to know or if it's saying that it's not part of the set, it has the E with a slash through it, meaning that it's not. So this means it is, this means it's not. So then here's our problem. We have here, we've given a list of numbers. We have 1, 0, 2, 1, 0, 5, 7, 4, 5, 7, and we need to create set K from it. Now, when we create a set, you only have to put the number in the set once, even if it's in there 5 times in the list. We only have to write it down once. So, for example, 0 was twice, but I only have it once in my set. So then if I looked at all of them and figured out the numbers in my set, I have 0, 1, 2, 4, 5, and 7 are all in my set. So that's my set K. So that's just how you create a set if it gives you a list of numbers. And you always put your brackets on both sides. All right. So then in my problem, I A, B, and C down here, they've given me 3 sets. Set A has 0, 1, 3, and 5. B has 0, 4, 6, and 7. And C has 1, 2, 3, 5, 7. All finite because we can count. There's a starting point and a stopping point, and that's done. So it's asking in A if 5 is a part, because we have the funky looking E, of set A. So we just look in set A. 5 is there, so this statement is true. All right. B, it wants to know if 4 is a part of set C. So we look, we have 1, 2, 3, 5, 7. No, it's not. So this statement is false. And then our last one, 5 is not a part of set B. Set B, 0, 4, 6, 7, that statement is true. So remember, finite, we can count. There's a starting and a stopping point for the numbers. Infinite, one of the points just keeps going and we can keep counting forever. If it is a part, we have this E. If it's not a part, it's that E. If they give us a list of numbers to put into a set, we put brackets and then put each number we see listed once. And then if we are seeing statements like this, it's just asking for a true or false. So is that statement true or is that statement false? And that's all for sets. So then the next part of this is going to be rearranging before graphing. So rearranging before graphing. So before we were given 2 equations, we had to figure out what y was, plug that into the other equation, and we got x. So, or we were just given an equation and we plugged in whatever x we wanted and we got y. So then this is a different way to rearrange before graphing. So our steps are, first we're going to solve for y. and then create a table for x, and then graph it. All right, so our first equation, it's telling us to graph 3x plus 2y equals 4. 3x plus 2y equals 4. Our first step is to solve for y. So we would need to get y by itself. So first we're going to move over 3x minus 3x. So we have 2y equals 4 minus 3x. And then y is still not by itself because we got the 2, divided all by 2. So y is going to equal 2 minus 3 over 2x. Or we can rewrite the equation y equals negative 3 over 2x plus 2. So then from there, we can make our chart. And I'm going to say 2, 0, 2, negative 2. So we are going to plug in 0, 2, and negative 2 into this new equation to figure out y. And if we did that, we would get 2, negative 1, and 5. So our ordered pairs are 0, 2, 2, negative 1, negative 2, and 5. And that would be what we graph. I don't have room, so I'm not going to graph it, but that's how we graph. So first we had to rearrange so we can solve for x, or solve for y, sorry, set up our table, and then we would graph our points. So I'm going to do one more. All right, so we're going to have y minus x equals 0. So we got to get y by itself. We're going to add x. So we have y equals 0 plus x. So y essentially is going to equal x. So that's our equation. And then we create our chart. It's going to be really simple. Just plug in some numbers there. And if y equals x, then they are the same. So my ordered pairs are 0, 0, 3, 3, negative 3, negative 3. And that's what I graph. And that is all for 56.